Got it, right?
Yeah.
Okay. So our first problem is like transpose matrix. We are given a matrix and we are supposed to return the transpose of it. Transpose is like flip your elements across the diagonal. These two will be swapped, these two will be swapped, and these two will be swapped. And yes, so no such constraints. I mean, these are the length. A array length will be less than 1k equal to, and each element will be less than equal to 1k again. Yeah. So how do you proceed like here?
So this is an easy problem.
Yeah. Yes, exactly.
And you are allowed to modify your input, or you aren't allowed. I think that doesn't make a difference, right? Yeah.
You're talking of in place.
Yeah.
Yeah, you can do, but is it possible to do in place?
The dimensions are not equal.
Pardon?
The dimensions are not equal, so you can't.
Yeah, if
Is it because for transpose? Okay, you are saying that you can have any dimensions.
Yeah.
yeah, rectangle. No, I think for transpose square matrix is required. No, not required. This is like any matrix.
Oh, okay. Yeah,
But to do it in place, I think we need a square matrix.
Yeah, that's true.
Okay.
So we have no other option than to create our own matrix.
Exactly. Yeah.
Okay. Yeah.
Otherwise, that would have been a nice one, like doing in place.
Yeah. Yeah, that's true.
Yeah. So, like, how did you proceeded? Like,
Yeah, just create another matrix of a different row and different column, the opposite side, right?
Yeah,
Opposite
sure.
columns and rows, and then
Swap it. Okay.
yeah, then actually go through each and every cell. Yeah.
So it seemed like this, like we are creating how many number of columns, those many number of empty cells, like this array, and then in each array you are correspond like B of 0 will contain A of Ji, like this it will fill with 2, 4, so it will come here, and again 10 minus 5 it will come, and this will come so on, and at last return B.
Right.
Right. Yeah. And time will be n square only.
Time will be O of rows multiplied by columns. Yeah.
Mn, yeah.
Space also will be the same.
Yes, yeah, it's sure. So any other approach apart from this, like?
I don't think so. At least I'm not aware of. Maybe anyone.
In place one, yeah, if anyone.
No, in place is not possible, right? So.
Oh, because of this. If it is a square, then it's possible, right?
Yeah.
But that. Oh, yeah. So then let's switch to next then.
Yep, I think this is an easy problem.
Hey, this is Prashant here. I just wanted to make a point that we can do a transpose of any matrix.
Yeah, you can do the transpose of any matrix, either rectangular or square.
Yeah. So I just heard that it should be a square matrix. So that is not the case.
No, that was for like doing in place. Here we are doing extra space, taking extra space because it is a rectangular. Sizes won't be different. Will be different.
Yeah, okay. Yeah, sure. Got it. Okay. Yep, thanks.
Yep. So next is like which container contains the most water. We are given n non-negative integers where each of them represents a point coordinate on x-axis, and n vertical lines are drawn with two endpoints at this and this, and first two lines which together with x-axis forms a container such that the container contains the most water. So we are supposed, these are the vertical lines which are attached to the x-axis, and we are supposed to find which two lines will contain the maximum water, will form a container with x-axis and contain the maximum water. And like you can see, for this case, it is 49. And yeah. Yeah, like, so how do you proceed here? Like,
So
so
the
7 7
first
or 49, this one, blue one. Yeah.
so basically we have to find the two most optimum bars, left and right. So we
Yeah,
will
which,
start taking a pair, like run a loop for the left and the right,
okay.
and basically the amount of water is going to be minimum of the height of the left and the right into the width.
Okay, yeah.
Talking about any pair. So that would be like running a loop for the left bar and one for the right bar, and taking a minimum of out of I and j and multiplying by j minus I.
The gap between those two bars, right?
Right.
Mm.
That is the first approach I would present.
So it's order of n only, right?
No, n square. I'll be
Oh, you
running
are,
two loops. So
oh,
one
Oh,
for
would
every
be
bar you will be running. Okay, got it.
he's saying the brute force, right?
Okay, okay, yeah.
yeah.
Okay.
Something like rainwater collection, right? The trapping water or something, right?
Yeah,
Yeah.
similar.
Yeah. So the difference is that in that question we don't have separation between the bars,
Yeah.
and we look for the total amount of water captured just above the bar. So we cumulatively find for each of the bar and then add them. Here we are looking for container sort of thing.
Yeah.
But in that case, you won't be able because that problem could be solved by many approaches, right?
Yeah, DP, divide, conquer,
Right.
stack.
Stack, yeah. But this is just a couple of them, right? We can't do more. I didn't understand why, because I think stack also can be a possible option, right, to use here.
Should work here. It's, I mean,
Here
two.
also it is looking like the same, right? Either max or max of left height or right height and the width. Just that we don't have to subtract the histogram height in between
Right.
height. Yeah, it looks like the same actually.
There,
Yeah,
the
it
water
looks
can be
same.
above histogram also. Yeah.
Yeah, that condition is removed. Now it will, I mean, min of those two heights and the width.
Yeah.
Yeah, makes
Here we
sense.
are looking for a boundary. There it was just one bar.
No, actually,
Yeah.
right? Because the similar thing can also be done over here, right?
Yeah.
We can have a main bar in middle, and then we have all the bars to the left or right of that one, lesser than that bar. Still, that also can be a possible option. I think all those options, all those approaches for that problem should be applicable here also.
But it will be extra add-on, right? I mean, stack and all. Extra space you'll be taking if you use stack.
Right, right. But at
Yeah.
least we have different approaches. That is what
Yeah,
I'm
definitely. Yeah, that's true.
just thinking loud. I'm not sure,
Yeah.
Aruti.
No. Last time, Praveen or someone has said without any space, right? You increase from either direction and you take only uh, uh, the
The
minimum
minimum.
height, and you calculate the since you already know the width here, you iterate only in the direction of min height.
Yeah, makes
Yeah.
sense.
I mean, it's like a two-pointer from both.
Okay.
I vaguely remember something like that.
So you're talking for that
That
approach for that one or this one?
I
No,
think
this
even
one
for
only.
this it
Oh,
works.
okay.
If you start from 2-pointer, use start in the end. Maybe
Yeah, without any space.
yeah.
For this problem you're talking.
Yeah, this one, like just
Yeah,
move
yeah, sure.
move the pointer whichever is less.
Hmm.
Yeah,
Okay.
yeah.
So then that becomes a very easy problem, right? Oh, sorry, I mean to say, if we
Yeah.
understand it, yeah, okay. Because we have worked on that approach, so yeah. So that is applicable here. Okay, good.
In single pass you can find.
Yeah.
Yeah,
So
you just
time
need to
complexity.
maintain some local max or like global max to calculate.
You want to share something like?
No, I
Max.
haven't implemented.
So let's talk.
So global max will be okay. Yeah. You just maintain some variable. That is what you're saying. Okay. Mhm.
Yeah.
Okay, can you see my screen?
Yes, yes.
Yeah. Can you just increase your font a bit? Yeah. Thank you.
Yeah, I mean, I solved this like a really long time ago.
Uh-huh.
So basically, whenever the size is less than 2, I'm returning 0. And the global max, I'm making it as 0 initial value. I'm taking 2 pointers, I and j. I starts from the index 0, and the j starts from index, which is the end of the array. And the while loop is I less than j. So basically, whenever I'm inside the loop, I'm calculating the distance between I and j, and I'm taking the global max. I'm calculating the global max. Whichever is the max, I'm assigning it to the global max. And this if else will reduce the I and j, whichever is less, that particular, if the left side bar is less, and I'll increment the left side bar. If the right side bar, yeah, if I is greater, then j will reduce, which is the end, which is the right side bar. If j is greater than the start, which is I is the starting bar, that will increase.
But in this line number 14, when you are saying j minus I, should it not be j minus I plus 1?
J
It's
minus,
the width we are taking. So
yeah,
that
width,
is,
correct.
Okay.
so if let's say we have I as 1 and j as 3, then the width would be 2. 3 minus 1.
Oh, okay. Sorry, I got it. Yeah. Okay.
Number of bars will be 3 if we do plus 1.
So it is a normal two-pointer approach, right? Okay.
Yeah.
But I think the movement of the pointers is something interesting to analyze. Because when we are solving 2-pointer questions, we have to take a decision at every step, like where to move.
So we have to move only when which height is lesser always, correct?
Yeah.
Whose
Right.
height is lesser? Because if you do it the other way, it won't work.
Right. So basically, if you look at this expression on line 14,
Uh-huh.
so j minus I is going to increase anyway. If I increase I or j, sorry, decrease. J minus I is going to decrease by movement of I and j. But but I have to optimize this minimum thing. So basically, this is why I think we are moving the minimum part to find a better minimum for the right one.
Okay,
The
nice
min
observation.
controls the water. I mean, min controls the water, right? That's why we
Right.
move from the min.
Yeah, but that's a good explanation. So, it makes us easy to remember this one. Yeah. Yeah, thank you. But do we have any other approach in this? I think the stack and all those things will still work, right? If we have a monotonic stack, or some sort of stack, or maybe they also use some prefix sum from the left side and the right side, and then they in that approach they are calculating for each and every level. I think that might not work then in this case.
Prefix sum.
Yeah. So you have a prefix sum array for the left side, and you have a prefix sum for the right side.
Okay.
And then for each and every one, each and every index, you find the minimum of it. So that approach, which works for that rainwater problem, it won't work here, I think.
Should
Ideally, every approach of the trapping rainwater should be applicable here as well. As I mean, that doesn't seem like anything. I mean, even this much easier than the trapping water. So every approach should work, I'm guessing.
But because that prefix sum, actually what we do is at each and every index, we find the minimum value, right? So then how do we
Oh
get,
yeah, prefix sum, yeah. Not prefix, I mean minimum till, I mean, yeah.
Yeah.
okay.
We
Okay.
find the maximum in the left, maximum in the right, take the minimum of both and then subtract. So I think that would also work here also.
Yeah, I think that one also works here.
Yeah.
Okay,
That
so
would be
you
like,
have two variables, one at the maximum was left side and the right side maximum, right?
right.
Okay.
So we find those, take the minimum of those and then multiply the minimum into the width.
Okay. Okay, that might work, yeah.
So as Uday said, I feel everything that works over there would work here, I think.
Work, okay.
No. Actually, what Santosh said might be true. I mean, if you're having the left height, here it would be Z. I mean, there we are actually calculating the left and right height to calculate the water that has accumulated at a particular tower.
Right.
I mean, the left or right height. So you actually take the minimum and you minimum minus the tower height and minimum of left and right max minus that tower height. You generally do it.
Right.
Here it might, I'm not sure actually.
Yeah, I'm also getting confused. Yeah, that's true.
So the difference
But
is that here we are multiplying with j minus I also.
No. There, in that two, the approach that is set by Santosh, we don't do any J minus I kind of thing. So we take the max from the left and max from the right,
Right.
and we take a minimum of these and subtract that tower height at that ith position.
yeah,
We don't
Right.
do any I minus J. I mean
Right.
the difference or something like that.
Right. So that is the extra thing because here we have widths also. So we do whatever we do in the previous thing and multiply by j minus I also.
not sure, but
Because
I'll have to try and see if that particular approach works here. Yeah, it will surely have a extra space, but we're trying it.
So mine is like similar to that of Sandeep. Like start, I mean, this is my start and this is my end, and I'll keep on. If my start is, as long as my start is, if my start is less than your end part, that means like this situation, this is bigger, this is smaller. The amount of water content will be equal to the height of this smaller one into the width of this. So just I keep on increasing, and other way, like if end is smaller, then I keep on decreasing and just update the max area globally each time.
Okay, so this is almost same.
Yeah, exactly. What you
okay.
Yeah.
Okay, yeah, and that is perfect. Yeah.
So any other, or shall we switch to next?
Yeah, actually, that was the DP approach what we were talking about, right? What was that? Yeah.
Oh, the
Okay,
one.
yeah, but
This
I'm
is
not
like
sure.
that of Sandeep's. Yeah.
Yeah.
Okay, then let's switch to next.
No problem. Yeah, sure.
So this is a max gap. So unsorted array is given to it. We are supposed to find the maximum difference between the successive elements in the sorted form. So here maximum will be, I mean, 6, this 2, like difference between 3, 6 and 6 9. But a constraint is like you're supposed to do it in a linear time. And you may assume all elements in the array are non-negative integers, which should fit in 32-bit signed integer range. So, I mean, without this constraint, this problem is like, nothing. The solving it a linear time.
Oh, they have specified that linear time and space.
Yeah, because of which it becomes hard. Otherwise, it's like they are telling us to short it and just keep on taking difference of two consecutive elements and update it, and whichever maximum you get, return the answer.
Okay.
Or I mean, what would be the brute force like?
Yeah, so the brute force would be just use any sorting algorithm, sort them,
Okay.
and then find the difference between the successive elements.
And update
Whichever
it.
is the maximum, just return it.
Yeah.
Yeah, I'm not sure whether it gets accepted or not, but that's
Yeah,
the brute force.
I have tried with that. It got accepted.
Okay, okay.
Yeah, but they are giving a constraint to do it in a linear time.
A linear time. So if we have to do it in a linear time, what is the best way to do?
Best way, yeah, somebody.
So would
Like,
we just use like a extra space and do it, or?
no, without extra space also, I think we can. No, we have to take. I like they uses the principle of PGP, pigeonhole principle with bucket sort. So bucket sort uses extra space, right?
Oh, okay.
Yeah, that is what they have mentioned in the discussion section.
Okay, and also one thing, these inputs, the values of inputs,
Yeah.
they are going to be all positive, and there is anything like the size of it, whatever the numbers are, whatever the numbers are inside the input array, they are going to be equal to or lesser than the size of that array. Something is
32.
there.
Mm.
No, I don't think so. Right? Okay, because the second example says 10.
Yeah, I'm on.
Because if you use something like a sort, what do you say, counting sort, so that won't be applicable here, right?
We'll take that as a base case, like element is less than 2, then it will return 0. Because for finding the successive difference, we need at least 2, right?
Oh, okay, yeah.
So why the value had to be non-negative? Why it cannot be negative? Maybe that could give us a hint.
But does it?
If we think about if it's negative, it should work too, right?
Yeah.
Yeah, I also thought that. Yeah.
We just take a difference, whatever the way it is. Yeah, I think there should be some other way also of doing it, right? Other than the what Shashank said. That might be optimum way of doing it.
Oh, in linear time, right?
Yeah, in linear time.
So like how anyone who approach like in linear time?
So in the solutions, they talk about that Radix Sort algorithm. Okay.
Yeah.
It's not a linear time, I think. It might be between the first approach, what we discussed, and then the one what you said, Shashank, right? It might be
Yeah.
between that. So,
Somewhat.
so that is also a good thing to try out, right?
Radix one, yeah.
And it is not that difficult also.
Yeah, that one, yeah.
But can we quickly run through that, how it is?
This Radix one I haven't tried.
Okay, so maybe just we write it on a whiteboard
Sure.
instead of doing that, right? And everyone can help us.
Yeah.
It will just refresh everyone's memory.
Yeah.
I had never tried that Radix Sort though, so it's a bit confusing. Therefore,
Yeah, exactly. And these algorithms are rarely used, so it is not on the top of our mind.
right. Okay, so no one is sharing. Okay, let me try then. I thought Shashank, you are going to do it. Okay, so how does this Radix sort work? Help me, guys. I've not done that earlier.
So it actually starts on the most significant bit, and so it will be as per the bits or digits.
Okay.
The first digit or second digit, something like that.
Okay, I'll just take some random numbers and then help me here. 47 and then maybe 5, 13 and 6, 79, something like that.
Can we write the numbers one below another? Because if we stack up, then the index will be very clear.
Okay, makes sense. So, okay, any examples you could think of? 73, okay. 215, okay. 679.
Just make it 673. So we.
Okay, so you have in the same, okay. And one more thing, do these numbers always have to be of the same digits? Means I mean to say the same size?
No. It doesn't have to be.
Okay, so I'll just take 1, 2, 8, 9. Okay. So what does it talk actually? The first thing is we need to find the maximum value out of this one, right? So in this, the max value will be, okay, we'll write our indexes here, was 0, 1, 2, 3, 4. Okay, these will be our indexes, right? And our maximum value here is 1289, right? So just write max is equal to 1289. And so now it talks about finding, okay, taking some array. Okay, so the array size will be, okay, if I have an array size over here, okay, so this size will be of 0 to 9, right? 1, 2, 3, 4, 5, 6, 7, 8, and 9. And now in this array size, actually I need to go and look for the last digit, right? In this case.
Okay.
Okay, so
So why is it till 9? Why is the array size 10?
Total digits used are 0 to 9 in the entire.
right. So I will just take the digits, any digits, like I'm currently taking the units place. So I'll just look at the last digit here, correct? So I'll have digits from 0 to 9 only. So therefore I'm having an array. Maybe I'll call this as a count array. That is what is called in the solution
we
also.
we have to take only the last. We have to start from these significant digit only, no? We can't start from most significant digit, no?
I think so. Yeah, that is a good question, but I think they have started from the last one, so I'll also take that. But that makes sense, right? Can you do it from the MSB? I'm not sure.
Because we can't do, because what I thought on that thing is that because first MSB basically decides the degree of the number, that is how much larger it is. If we start from MSB and arranging on the basis of first MSB itself, then it will not give it the correct ordering. So therefore,
Okay.
we are going from LSB. What I think.
Okay. Yeah, makes sense. So, okay, in this case, if I take these ones, so what I will have is I will have 1 here as 1, okay, in this one. So 3, I will have 2, right? Because we have 2 3s, and I have 1 5 and 1 9. Okay. So when I'm done with this, actually, I need to do a cumulative sum here, right? So in this case, if I do a cumulative sum, I'll just write it below this array. So this will be 0, 1, this will be 1, and this will be 3. This will be 3, this will be 4, this will be 4, 4, 4, and 5. Okay. So now when I'm done with this one, I need to actually have another auxiliary array. So I can, instead of writing it, okay, I can write that auxiliary array here, right? Okay. So this auxiliary array, so this auxiliary array size will be same as the input array size. Okay. So I'm having about 5 of these. Okay, 1, 2, 3, 4, and 5. Okay, now in this case, when I go through each and every element of the auxiliary array, now I take the input array first, 3, this index 3 to 1. Okay, in this, I go and find out what is the least value in this case. It is 1. So here I come on the count array. Okay, I find where is this value? Actually, it is at location 1. Right, so I go and first actually subtract this value from here, which makes it 0. Okay, and then so in this case I write this 3 to 1 at the 0th position. So then I actually go for the whole auxiliary array one by one. So I go for 4, 7, 3. So the second one now here in this case. So this lies in this okay, in this element. So this is the value is 3. So I reduce that 3 to 2. Okay, so this is 0 and 2. So I write 4, 7, 3 here. Okay, and then I go for the next one, which is 2, 1, 5, which I come here. Sorry,
I couldn't follow you. Could you please repeat that step again?
okay, so in this case, okay, I'll go back to this one, right? So when I was at 4, 7, 3, okay, so I just took the last digit, which was 3.
Correct.
Okay, so I come to this 3 index on the count array.
Right.
Okay, so when I come here, I just find what the value is. Here the value is 3.
Correct.
The cumulative value. So I decrement that value first, make it 2. So I take this 2, okay. So this 2 I take and actually look at the auxiliary array. Okay, so the index at 2 is over here. And therefore I place 4, 7, 3 in this place.
Oh, okay.
Yeah, and then I come to 2, 1, 5. So I actually look for this fifth, this will come at 4, this location. And so the value is 4. So I reduce it to 3. Okay. So then actually this is my location 3, right? So I just place this 2, 1, 5. Okay. So then when I come to 6, 7, 3, so this is again the third index. So I reduce 2 to 1. Okay. So I come here and this fits in this slot 6, 7, 3. Okay. So the last one is 1, 2, 8, 9. So this is 9th and this is the 5th one. So I reduce that to 4 and the 4th one is here. So I just do 1, 2, 8, 9. Okay. So when I do this, I actually now make this auxiliary array as an input array. I copy all these elements over here now because I've already sorted the last digit. Right. So when I copy that, so all of these will become, I'll just change it now here. So this was, I think, yeah, I'll have to change most of them here. Okay. So this will be 6, 7, 3, 4, 7, 3, and 2, 1, 5. I'm sorry, I destroyed the input, but yeah, this is what it is. And then again, I do for the second digit. I repeat the same thing. Okay, so again, I'll have to do the whole exercise over here. Right. So if I do for the same thing again for the second index, then I will get most of them at the right places. Okay. So if I do for the second index, so we have 2. So in this case, I have only 2, 1, and we have 7 2s. 2, 7, sorry, and 1, 1, and another one is 8, 1. Okay, so if I do again the cumulative, sum of these one will be 1, this will be 2, 2, 2, 2, 2, this will be 4, 5, 5, right? So now
So
I
what is
start
the
with this.
intuition behind taking the prefix sum?
Because if we take the prefix sum, we are actually finding the indexes where all of them will be there, right? So at the end, so now if I go for this 8th index, okay, so it lies at 5th place, right?
Right.
So 5th means in the sense 5th, it is a 1 base index. So 5 minus 1 will be the 4th index. So that is the place it will lie. So if we have 7, we have 2 7s, right? So if we say 2 7s, we have 4 and 3. It will be because the previous one starts from 2.
Okay, got it.
So we are just trying to maintain the indexes. That is what it is.
Right.
Yeah.
For the current bit.
Yeah, for the current
Like,
digit.
can't we make 10 buckets and for the 10 digits, because there will be only digits from 0 to 9 only. So
Right.
like, can't we take 10 queues, 10 different queues and push them on the basis of the digits in the queue, and then popping it out and pushing it to the array.
That is a good way of doing queues, but I didn't understand what you want to put in a queue. Every digit.
Like, yes, basis on the basis of the last digit, like 3 to 1. So 1 is the last digit. So it will go into the first index queue. If 0 is the last digit, so then it will go in the 0th index queue. If 3 is the last digit, then it will go in the 3rd index queue, like that.
Yeah, that might be possible, but I think this is the way it is explained on this Radix Sort. So I'm just going through that, but that is the other way of doing it. Yeah, it might be more efficient also. But I thought this was also an easy way of understanding,
Yeah.
Yeah, so that's the reason I went through that. So now if I look for these ones, again, I will be able to do, if come for 3 2 1. So I'll come at this index, it will be 0. So I'll put this 3 2 1 and then go for this one 6 7 3, which is here. So I reduce that to 1. Oh, I'm sorry. I should go for I'm very sorry. I messed up with this. I have to look for the second digits, right?
Yeah.
Yeah, so in this case, so first will be 2. So I will come here. 2 will be 1, right? So 3 2 1. Okay. Did I make mistake there? So 3 2 1. No, it is right. So 3 2 1 will be 1. So I'll be. Oh, what did I do? Yeah, there is something which I missed.
Yeah, actually we got the crux we got like.
Right. So, but yeah, there is something which did not work yet, but yeah, but it should work the way it
There's
says.
somewhere
Yeah.
mistake.
Yeah, I'm sorry. Yeah, why I missed that?
It's okay. We got. So, but
So
extra.
after this,
Okay.
so after this, we have this sequence in a sorted way. I mean, and then we kind of go on the sequence, go on this array and find the difference. That how we do it.
Yeah.
It's already sort now. It will sort the numbers.
Okay.
It is also basically doing sorting only, right?
Yeah, this is doing sorting, but it is doing sorting, digit by digit.
With the extra space also.
Yeah, it's
there's an extra space.
But it is very only 10 only 10 spaces there, not very bigger than that. So it is like constant only.
No, but auxiliary array would take space of O1, right?
Yes. Auxiliary array will take space of ON, and then we'll have a count array also. So we'll have both of them. Yeah.
Like I implemented it with queue. Then I took only 10 queues,
Okay.
and I didn't those 10 queues are only storing the numbers and pushing it in and popping it out, and storing it in the array, given array only.
Okay. You want to share your approach?
Uh,
Ashish, right? Okay.
Ankur.
Good. Ankur, sorry.
Visible?
Yeah.
So like what I did is that first I found out the maximum element in the array. Then what I took is that this is the one exponent which I will use to reduce the digit the base by base, like the decimal digit number, then after just 10th digit number, then 100th digit number, like that. So I will do till that maximum element by this exponent, that exponent is less greater than equal to 0, and I'm increasing it by 10 every time. So I'm passing it to the this function. So I took an array of 10 queues, and I'm pushing it on the basis of this last digit. Actually, it is extracting the last digit of the number, and I'm pushing it to in the queue. And then I'm traversing these 10 queues till the ith queue is not empty. I'm pushing it to the number that in the array. What actually we are making buckets. On the basis of buckets, I'm distributing the numbers in different queues, and then I'm incrementing that storing in the array, and then copying it one by one till its ith queue gets empty.
Okay. Okay. So in this for loop, actually on line 23rd, so you are actually your exp, that expression,
Exponent.
Yeah, exponent. It actually separates the digits, right? The first digit, then 10th digit. Okay. So you are just separating them.
This is extracting the number, basically the last digit, last one. Mod 10. That therefore I'm doing mod 10.
So you're taking the last digit over there on the line number 8, and then you're pushing in that array.
Yes.
Pushing in the queue. Sorry, right? Yeah.
Queue. Yes, sorry.
So here that queue is taking the role of that count array, right?
Similar, yeah.
Slightly different though, yeah.
No,
But I don't
actually,
understand why.
counting sort has both the variations. This is all the counting sort only. You can actually sort in the counting sort without adding the cumulative as well. Here you use it queue. Both variations are there for counting sort. Either adding cumulative sum or not.
Okay.
But for counting sort, I think that the index, the value range has to be less than equal to n, I think.
Yes, the value range has to be then has to be there. But I'm just taking the help of the last latest digit of the, and then deciding that only I'm putting in the desired queue, and then I'm popping it as it becomes empty.
Okay.
Like what I first I thought that, because this in this question it is given like that we have to solve it in linear space or time. So then I thought that how this will work. So basically the time complexity, what we get here is that it depends on the base that we take here, like 10th base, or it depends on the base of the number and on which we are dealing. Suppose what I know is that suppose the complexity is this one, like d into n plus b. Here d is here b is the base of the digit, and n is the number of elements, and d is the maximum element. That what are the maximum number of element, and what are the maximum number of digits in the maximum number of digits in the maximum element of the array. So this gives an almost constant, but
So it's n
this
log n only, right?
no n log n it happens, but if we take that because d is actually the order of log of b, like log to the base b k.
So d is log n, right?
No. Here,
If
here,
what is it?
yeah, in this.
Like
You can go.
if we take the base very larger, like if we take base larger, like a large k, then it can take over, like it can do on also in of n this Radix sort if we take k as larger in some cases,
Yeah, but I
but
don't think
on
it
an
is
average.
log. It is not required to be log, right?
Yes.
Yeah.
That's
So
I
it
was
is
saying
just
that,
that D is the number of digits, correct?
yes.
yeah, so in the worst case, like if the number is 2 to the power 32, so we have 32 bits, right? So that is log of 20.
Mm.
Yeah, okay.
Yeah, that's good. So this is also almost O of n. Yeah, right?
Yeah.
Almost often.
Yeah.
But what I saw is the third approach is very, very difficult. Like if anyone has done he has seen that, because it was very difficult to find out what are the gaps they are taking and how they are segregating the bit on the basis of
Yeah.
bucket within a sorting.
Yeah. Okay. One thing what I messed up, in the last what I was discussing, I should have started from the last value.
Yes.
Okay. Yeah. So if I do that, then it will work. Then only the cumulative will work. I'm sorry. Yeah, I didn't
That only
follow
will
that.
that
Yeah.
will only work because
Yeah.
on the basis of least significant digit, first we are deciding that what in which queue it will, like in which position it will go. Because if
Yeah.
we decide on the basis of first digit, then the most significant, then it will not, because we are giving less importance to most significant digit. We have to give more importance to it. Therefore, we are taking it last.
No. You can actually do from both ways. Actually, you just need the digit at the particular position itself. I mean, you can actually take all of the digits. I mean, the integer max value is some 2 into 10 power 9, right? So you can assume that max there can be only 10 digits, and you can start with the 10th digit. But most of them will be zeros, but you can actually do from MSB as well.
No, but how how will decide it at last? Because at last position it matters now. Like, because if we do from MSB, then according to the last digit, it will go into the position the count array or queue. So that how it will give me the correct position in the sorted array, because it may not give me the correct position in the sorted array. That is only the case here, that we should get the correct position in the sorted array. How can ensure that?
Yeah, I'm not sure, but yeah, it might be worth trying it. Yeah. Yeah, no problem.
Like I have not
But
seen
I
any
think,
implementation of Radix sort that do with start with MSB.
yeah, but wherever you place, see any digit you take, whether the start or the end, because what you're trying to do, put each and every number into a bucket, correct? So whatever the way you sort it should be possible. That's what I think. But yeah.
Like what I understood is that because on what we are doing is that, like, we are iterating over the exponents. So at last we should get the correct position in the array, because and that correct position will give me the most significant digit was the main thing. Because suppose 3 is there, so on the basis of this one it will go into the correct queue. Like if we go with this one, then it may not give the correct position of the number. What I think.
Maybe your argument is true, but yeah, maybe the other way also it can be done. I never tried it, but if try, then only we'll come to know whether it is correct or not. But logically, it might be possible. That is what I think. But yeah, yeah, no problem. Yeah, this is
So
good. Yeah, I think you use the queues, and that is also good.
this
And you
is
are
what
not
I find.
using a, yeah. Yeah. So in my cumulative approach, only what I should have done is when I'm looking for that cumulative count, I should start from the last index actually. If I started from that last index of that auxiliary array, then I could have actually reached the right place. So, okay, let me quickly go through that again, maybe. Or, sorry, actually. Yeah, so if I take 1 to 8, 9, the first one, I should actually go from the, the last one, actually, not from the first one. So if I should have started from here, that is what it says, if I go for this 8, I come in this 8, I reduce this 5 to 4. Okay. So I now put this one here, 1, 2, 8, 9. So then I go for this index.
But
That is
it won't be
215.
much difference also, I think, from top if you start.
Yeah, so that is what it says, So, or else they would not have stated in that solution. So it is like if I go to 215, I just it becomes 0, and so my 215 comes here. Okay, yeah. Yeah, so maybe I'm not sure though.
Yeah, we'll check it.
Yeah.
It's like almost same thing. Like we have confusions either starting from top or bottom, right?
Yeah, maybe if we actually keep on doing it, then it may be in that right position. If you go to the next digit, yeah. Yeah, sorry.
Yeah, no, it's okay.
Yeah.
So here
okay.
also like.
I'll try that later and see if I can post it. Yeah, no problem.
Sure. So one was like this PGP, like pigeon root principle they were using, right?
Yeah.
The second one. It is like if we had number like what do you say? If we have 3, we have 3, 6, 1, and 9, right? So what I see pigeon root principle, what it says like let's say if we have 3 pigeons, then we are supposed to use only 2. What do you say? The hole to keep that pigeon. I mean, in one hole, 2 pigeon has to go. Any other in any one of the holes. So,
right.
Yeah. So what they are doing is like, yeah. So here they are first finding the maximum and minimum number in this. Like your max is here what 9, and min is 1. And now they'll try to find the average interval between the numbers. It's like 9 minus 1, 8, and average interval. I mean, how many gaps will be? If there are 4 numbers, there will be 3 gaps, right? 1 gap, 2 gap, and 3 gaps. So 4 minus you do. So the result comes out to be something 2.33 or something like that. And since the number of what do you say total numbers are 4, so we'll take 3 number of holes, because just now we looked at pigeon, we need to keep 2 numbers in one hole. And after that, what they use, they take each of the numbers, like they'll take 3 and subtract the minimum number in it. Yeah.
Prashant,
So
can you explain this one, like how you did the 9 minus 1, why you took 9 minus 1 there, like to get the range, no? Like
average interval between each of total range, like if distance is given a to b, and if I have to find how many stations are there in between, so you take the minimum and take the maximum and divide by the number of gaps in it, so length of each gap you will get, right? Like
why 2.33 you are making it as 3?
because this is 4, right? Total numbers is 4, right?
Yeah.
So and pigeon hole principle, what it says, if there are n numbers, you have to take n minus 1 next. I mean holes in which you are supposed to keep the pigeon.
So directly we can get, right? Then by doing if there are n, then why this calculation 2.33 and making it is 3? Hello.
But difference between, I mean, yeah.
No, he's trying to say like so you have this range, right? 9 minus 1 divided by 3. You are saying you are taking 3 because you are having 4 digits, right? 4 numbers.
Yeah.
So 4 minus 3. So 9 minus 1 will be 8. 8 divided by 3 will be how much?
2.33 something.
Yeah. So she's
I think
saying
that
why you
it's a
take
coincidence.
3, why not 2? because
a
it
coincidence.
is integer division, right?
Yeah.
That also makes sense. Should be possible with 2.
That's a good question. Like, I mean, maybe it's
Yeah,
here. It's
because
like,
you can see, you can use a bucket size of 2. Okay,
okay.
so that is okay. But using that bucket size, actually, you want to find how many buckets you require, right?
Yeah.
So then you can actually again use your range, which is 9 minus 1 divided by this bucket size, which will be 8 divided by 2 will be 4, right?
Yes.
And then instead of 4, because if you say if you divide this by 4, how you can divide? Like it will be 1, 2, then 3, 4, right? 5, 6, 7, 8.
9.
And
Yeah.
so 7, 8. So 4 buckets will only be till 8, right? So you'll
Yeah.
have another bucket. So maybe it should be 4 plus 1. So you should always have. So it will be 9 minus 1 divided by 2, whatever was the bucket size. And whatever that answer comes, you should add 1 to that.
So
Yeah.
it will be, then again, same we will have.
I'm sorry.
The same result it will also come, right? After adding 1.
Oh yeah, so you're saying that instead of 2.33, if you take 3, it will be the similar. That is what you're
Yeah.
trying to say.
Yeah.
But you are actually trying to reduce the bucket. You are trying to increase the bucket size, so the bucket counts will decrease. Yeah, that might also be possible. Yeah.
The larger the interval, the lesser the buckets you will have.
Okay.
I think the purpose is to make the bucket,
Lesser.
one less than the available number, right? So that 2 number will fall into 1 bucket. But in this case, let's say we say the bucket size is 2, right? If the bucket size 2, that means we're gonna have 4 buckets. And since the input have 4 number, then each of the number gonna fall into each bucket. Then we never have like 2 number fall into 1 bucket. And I think that's why we pick 3 instead of 2.
Okay.
So that 2 items should fall in 1 bucket, right? Any 2 items.
So
yeah, but I'm not really clear about the bucket size.
Right. That is fine.
It's following something like that PGP. I mean, what I got is this much, but I think because see, you can't take 2 definitely because actual itself interval is 2.33, right? You can't reduce the interval. So we are taking the next possible integer that could be. And here 4. I mean, it's a coincidence that n is 4 and it is coming out to be 3.
Well, I would argue in that case, you can take 2 also or 3 also, both will be possible. Because what will happen, your bucket size will decrease in one case, in other case it will be more. But if your bucket size decreases, it means you will have more number of buckets, right? And if your bucket size increases, your bucket numbers will be lesser. So either of it should work, I would say.
So here it
but if you have more number bucket, then that wouldn't help in terms of pigeonhole principle, right? Because I think at the end we want, 2 number fall into the same bucket. If we have more bucket, then, we can distribute the number on each hole.
Yeah, but anytime we will always be focused on the number of elements what we have and the range, right? So even if we are going to have, we are not going to have bucket for each and every value of an array, right? So we'll still have a range, but the range size will be only the borderline will be a small thing we are trying to,
create.
Yeah. So we are trying to consider that portion. So yeah.
Mostly I've seen taking seals only, like.
Yeah, it says that the bucket size can be between 1 and this number.
1 and 3.
1 and what you calculated, 2.33. That's the first step. But for simplicity's sake, it takes it to be what you choose. Max minus min by n minus 1.
Yeah, so yeah, that is true.
Yeah, so once you get the interval, you just you take each of the number and subtract the minimum from it and divide it by the interval. So
Okay.
here, I think I'll have to clean it. So one is 3, the other is 6, and one is 9, and other is this one. So 3 minus minimum number is 1 divided by 3. So this will be 0. Then 6 minus 1 divided by 3, this will be 6 minus 1 is 5, right? So it will be 1. And 1 minus 1 by 3, this will be 0. And 9 minus 1 by 8 by 3, if we do, this will be 8 by 3, 3 to the 6, right? So you'll have buckets. One bucket will be of 0, one bucket will be 1, the other will be 2. So 3 will fall here. 1 and 3 will fall here, and 6 will fall here, and 9 will fall here. Now what we do, so it's like on a number line, like 1 is here, 3 is here, and this is bucket 6, 6 is here, and this is 9 is here. So we take the difference, you take the maximum in this and minimum in the second one, and take the difference of these two, will be 3. I mean, we have sorted it like, isn't it? 1, 3, 6,
Yeah.
9 without, it's a kind of sorting. And again, when you go here, take the minimum in this, since you have only one element, so minimum itself is 6, and here also you have one element only, minimum is 9 only, maximum is 9. So 9 minus 6 you do, that will be 3. So from first you take the maximum, second you take the minimum, and get the difference, and next do one, keep on updating the difference, global difference, what you say.
So one thing I was wondering, like if you have 1 and 3 in the first bucket, and you are trying to compare the gaps between 3 and 6, right? And then 6 and 9.
Yeah.
But in this case, it might not be a good option. But why not compare a gap with 1 and 3 also?
Because they are falling in the same way, they are falling in the same bucket only, right?
Oh, that is okay. But what happens if that bucket width is more, and we have only 2 elements, and the other buckets, or that condition will never come?
It will, yeah, it will. That's why we are avoiding, because of it, by taking the interval, right? Interval will, isn't it? In same bucket, interval will never be, what you say.
Wait, what you mean, like best case would never come, Santos?
No, what I'm saying is, when he says we have to take those gaps between 2 different buckets, right? The minimum and maximum of each and every bucket. Okay. So that is what we are trying to consider for the gap, max gap. But why not consider 1 and 3 also? In the same bucket, we have minimum and maximum value. So why don't we also see the difference and take that into consideration for a gap?
Yeah, that's what I say. I don't understand why we don't compare within the same bucket. Why we have to cross the bucket?
So then what was the use of creating different buckets? I mean, that's not a reason, definitely.
No, I understand what you're trying to say. It might be working, but it's not actually, giving me a satisfaction of why we are doing it that way.
I think elements in the same bucket.
So in that case, we'll have to be very careful about the bucket size.
Yeah, bucket size, like?
Because your bucket size should be minimum, okay? So in such a way, or optimum, in such a way that, the cross buckets, the minimum maximum gaps will always be more than your min and max in the same bucket.
I think here only the rule of PGP comes, right? 1 and 3 is coming in the same bucket.
Mm-hmm.
You have 4 elements, 3 buckets, and 2 elements are coming into 1 bucket. What would be the reason?
Yeah.
Somehow we have to prove that, the size of the bucket. The size of the bucket always smaller than the one that we do the cross bucket. And how do we prove it? Because we only take the difference between the maximum of the current element, the maximum of the current bucket and the minimum of, the minimum of the current bucket and the maximum of the previous bucket, right?
Yes. So here, why can't we take difference between these two?
Yeah, I think if we have two buckets, consecutively one next to each other, then there's no way that the cross bucket would work, because the maximum of the minimum of the current bucket and the maximum of the previous bucket will be always less than or equal the size of the bucket. Right? Maybe you can draw something, because it next to consecutively next to each other.
Like initially, like 1 was here, 3 was here, and 6 is here, and 9 is here.
So yeah.
So earlier we were taking difference between these two.
So let's say the maximum of the previous bucket, in this case, is right at 1, right?
Okay, you're telling maximum lies at 1.
Yeah. So that's the maximum of the previous bucket, and then the minimum of the next bucket will be at 3.
Okay.
Right. So if we subtract the difference, then the difference would be the size of the bucket, right?
Yeah.
So that would mean that there must be a gap between two buckets, because if two buckets are consecutively, then the difference is always maximum to be the size of the bucket.
So even if you say they are consecutive, it doesn't mean that the bucket, the starting of one bucket and the previous max actually will have almost 1 as a gap, Yeah, it can be anything. In this case, how it is like 6, and then we have 9, because we are actually creating the bucket size based on the minimum and maximum values inside that array, right?
Yeah.
So
in
it
this
won't
case,
be very consecutive, because it might be bigger also.
But in this case, the answer happened to be the bucket size, right?
Yeah. Therefore, I was also thinking, why not you compare inside that? But it might not be possible to do that, because the bucket size has to be chosen in such a way that it has to be a minimum or something like that, maybe. So you won't come across this situation. Maybe.
Why can't you compare inside elements? I mean, what you were telling?
Because they are already smaller. The value will always be small, because the bucket size will be in such a way that you don't have to compare it, because it will always be smaller than your actually cross bucket comparison.
So this distance will be always greater than the internal distance between any two elements, right?
Right. So
well,
that is the reason you will have to choose your bucket size.
Yeah, but it could be smaller or could be equal. So if we think about this case at equal, right? Because if you think about, within the same bucket, we have different, the size of the bucket the same as the answer. So it could be smaller than or equal, but
yeah. So that would be more important actually, the way it is selling. But anyway, if we do it the way he is explaining, it should be okay. It should work.
I think Uday shared something.
Okay. Go ahead.
No, the doubts you're having, it's explained in the first comment. I mean, the pigeonhole principle. There is a in the first comment, someone took time to explain why, even if there are multiple numbers in the same bucket, why you still need to contain compare the
Outside
numbers
bucket.
between buckets itself. No, not here. In the discuss third thread or something.
For this one.
Most words go by that. No. Go to discuss. Sort by most votes.
Where is that option?
Most votes, yeah, in the third option.
Yeah.
After hot, newest to old, and then the most votes.
Oh, this one here.
Yeah.
The third one, there's a comment explaining why. Can you go down? Yeah, here someone has explained.
So this is like we calculated the intervals, right?
Yeah.
And this is like what I did.
The buckets itself.
Bucket itself, yeah. And then we use extra array, max interval and mean interval to record maximum minimum of each interval.
So basically they are saying you just need to compare the max in the current interval and min
in the next one.
Yeah, one.
Mm-hmm.
So even if there are multiple, he says that about that as well. If there are multiple numbers in a single interval, then there has to be an empty interval, and max gap is larger than a single interval.
Okay. So if we follow exactly the way it says, then we won't have to do that. Okay.
What here? I mean, what is they are saying? People saying.
So basically, they are saying you need to get the maximum difference between two elements, right?
Okay.
But if they happen to come in the same bucket, they are saying since you have n buckets, that buckets is also based on max and min, right?
Yeah.
Yeah. So if multiple numbers happen to be in same bucket, there has to be at least a single bucket that is empty, and the buckets. Since the difference the gap is increasing, right? In a bucket, the gap can be only k itself. But if multiple numbers lie in the same bucket, the gap increases more than k.
K is what?
The range
size.
of the bucket length you can consider. Here he's giving that minimum plus k, right?
Yeah.
The bucket length.
Yeah, k the size of the bucket.
And the maximum gap is larger than the single interval. Yeah, that makes sense. So if you have one, by which I mean if multiple numbers appear in the same interval, you can simply ignore the number which lies in the middle of the interval. Yeah.
The gap increases by k, so they are not taking it.
Yeah. So if we just follow now, it will work. Yeah, and then that is what actually satisfies our argument. Yeah.
And the maximum is larger than the single interval. Multiple numbers appear in same interval. Why this is saying which lies in the middle of the interval? We can safely ignore the numbers which lies in middle.
Because if it lies in the middle of that interval, it is going to be lesser than the bucket size, right? So the cross bucket difference will always be more anytime.
Okay.
The more elements are there in a single bucket, then the difference between those bucket or bucket size and the gap, so it will always be lesser. But if you have a single cross bucket gap, actually, it will always be more in that
More.
case. Yeah, so you don't have to bother about that actually.
So in our case, in the example, we have two number in one bucket, right? And the other bucket have one number. So one of the bucket have many number too, but the value, the answer is still okay.
Come again.
The one we go through,
1, 3,
we
6,
have
9.
we have three bucket, right? And one bucket, the first bucket have two number, the second bucket have one number, and the third bucket have one number.
You're right.
So one of the bucket have multiple number, right?
Yes.
But in that case, the answer is still okay. It's not like crossing the bucket.
Yeah, because if it is k was 2 in that case, right? 1 and 3. So it is 2 in that case. But if you cross the bucket like 3 to 6, it will always be more. It is 3. So it is more than the k value, right?
Yeah.
So that is what it's saying. If you have any bucket more values other than only one value, so then you don't have to consider anything in that bucket size. So therefore, you have to always go through cross bucket because you will have at least one bucket which will have only single value or maybe lesser values. When it's talking about single value, if you have n number of more number of this elements in an array, so we just have to say how many elements are lying in one bucket. So at that time, the number of elements lying in one bucket may be 4, and if you have other bucket which is 3, so if you still compare those cross buckets, you'll always get the value more.
Yeah, I think the bucket size very important here.
Yeah.
And the important thing is to find the bucket size.
Yeah, that is true, but it is an automated way of doing it. We don't even have to think. But only thing is, if someone asks us, then we have to be ready with our explanation, right? Yeah. So this is the way only it will work, and that is the only way everyone will do it, right? So finding a bucket size. It's like an autopilot. We'll always do it that way. Most of them. So I would say always use a bucket size lesser, smaller side always. Don't go for the bigger one, because if you go for the bigger one, then the cross bucket comparison might be a problem. That is what I would say.
Cross bucket will be smaller compared to inner elements.
Cross bucket will be more always, right? Because if you have a bucket size smaller, right? So the cross bucket will always be more because it's like the reverse formula, right? If you have if the bucket size more, then the cross bucket might be, it might be a problem in some cases.
So if bucket size is more, that means the interval is less. That's a bucket size because interval is in the division factor, right?
Yeah. So.
Yeah. So if the bucket size more, then yeah, more number will fall into a bucket, right? But
okay, both are.
How do we know that's not going to solve the problem?
Yeah. So either of the way you use it's not a problem, I think. But as long as this argument says what Uday was pointing. If any single interval contains more than one number, then there must be an empty interval and a maximum gap is always larger than a single interval, right? So that makes sense.
When to use this, like in which type of questions should we use this PGP? Like any
Sorry,
template?
shall I?
I mean, I'm saying in which questions are we supposed to use this principle PGP? Like here we use next time, what category of questions? When we have to do sorting in linear, something like that, or
Usually, whenever we have numbers and we have to find an ordered thing, right?
okay,
So I think this is a good option because even Radix sort also will be a good option, or the bucket sort.
yeah,
Because if you
space it
have numbers, then you don't have a n log n version, right? In the Radix sort, actually, it is doing lesser than n log n, but it is not equal to n log n for sure. It
yeah.
only depends on the number of digits. And also, this is much better than the Radix sort
But
in some
extra space
cases.
is also using because of buckets.
Yep, you will need extra space for any sorting.
Yeah, yeah, definitely.
At least some extent, you'll in some cases you might be able to do it. Like I think merge sort there's in place, right? So
That is also extra space for merging. It is taking, yeah.
yeah, but they say it can be done very efficiently if someone does that. Yeah. So there might be a lot of applications. Whenever we see if there is some ordering which is required, then these things are very handy.
Yeah. Yep.
Yeah, that's good. Yeah, good discussion. And yeah.
Do you see any, problems using this pigeonhole principle before?
One is like forming arithmetic sequence.
Forming arithmetic sequence. Okay.
Yeah, like numbers will be given, array of numbers is given to you, and you are supposed to find whether all these numbers form an arithmetic sequence or not.
Okay.
So one way is like you sort the numbers and take the difference between two consecutive. If they are same, that means they are forming AP, right?
Yeah.
Otherwise, the other way, that is n log n approach, like you are sorting and doing all those things. But here, if you use PGP, then in order of n, you can find out whether that array will form a arithmetic series or not.
Oh.
So whenever you're finding a gap, AP is almost similar to finding a gap, and if they all are same, then it becomes an AP, right? That's what I'm trying to
Yeah,
say.
exactly. Yeah.
Okay, but then how come the bucket sort will be useful there? Because in bucket, in that AP you'll have to find a gap between each and every consecutive element, right?
Yeah, like A, B, C is there, right? A minus B and C minus B. Yeah.
Yeah, so you will have to go through each and every element. But
Yeah.
in
So
the
you're
bucket sort, here it is not that required, right? We just want to, group them in such a way that similar properties come together, and only we see the maximum gap between those two groups, right? Yeah.
I saw in one of the solution they were using like this pigeonhole principle. Like today I came to know when I saw this problem solution.
Yeah. Well, I'm not saying that it's not possible. I'm just trying to think loud.
So you're telling that if two elements fall into the same bucket, then like on what context you are saying that it will not follow, PGP will not follow in arithmetic means?
No, what I'm trying to say is it will follow, but it will
Yeah.
be more work, right? Because instead of bucket sort, you could use even Radix sort, because you'll have to do sorting for each and every element. In this case, we are not really doing a sorting, right? We are just trying to group the numbers, and if they fall in the same group, we don't care whether we are sorting them. We just try to find the gap between the two intergroups, right?
Okay, yeah. Yeah.
Yeah.
That will be add-on there, yeah.
Because we don't need to actually really sort. the way we do for heap sort also, right? Actually, the heap is not maintaining everything sorted, but only when it's trying to give out, then it appears to it's being sorted, right?
Sorted,
yeah. So similar, the bucket sort also is not really doing the sorting for each and every one, because arithmetic progression will always require. Oh, sorry, it's an arithmetic progression you're talking about, or you're talking about arithmetic sequence? They,
1, 2, 3, like it's an arithmetic sequence, right?
So in that case, you will have to look for each and every element, right? The difference between each and every element.
Consecutive difference, yeah.
Yes. So in that case, you will have to sort each and every element. So maybe some other algorithm might be better in that case. That is what my thoughts are. Maybe, yeah, you might be right. Or how they was saying something.
Actually, I mean, I saw it different approach, but it is not pigeonhole. Might be wrong. So I took the two minimums and I compared with everything.
Oh, really?
I mean, no, not this one. The arithmetic one.
Okay.
You don't need to sort it actually.
But that will be a brute force way, or it was?
No. Basically, you are given numbers and you need to find whether it forms an arithmetic progression or not. So for that, you just need the first two numbers. Then onwards, you just you know whether it will form arithmetic progression or not. So basically, you have the first minimum and second minimum. Now you know the difference. If it has to form the arithmetic progression, you know the D, right?
Your difference.
A plus D. Now you know first two numbers are D. So from then onwards, you can you know what are the rest of the elements should be.
Okay. So you just find if it's not matching the D, and then you just exit from the first one.
Yeah, you can keep it in a hash map and you check whether that element would be there or not.
Okay, yeah.
So I think that for the bucket, there's also sorting, but it does not sort all the number. It only sort a represent number only. Because if you think that for each bucket, we get the minimum and the maximum, right? And for the next bucket, we also get the minimum and the maximum. But if the minimum of the current bucket have to be bigger than the maximum of the previous bucket, right? Previous max bucket. So in that way, we do see that sorted, but did not sort all the number. It only sort like the representative of each bucket.
Right. Because that was required in this question, therefore we are doing it. Yeah, that's right.
So I think that's a way that save a lot of computation, right?
Absolutely.
That's how it's bringing up to big old man.
Yeah, makes sense. Yeah, sorry, Shashank, go ahead. Sorry. Okay, you got this one. Okay. Hey, Shashank, you are mute.
So I'm saying exactly we are not using pigeonhole principle here, but somewhat like the concept similar to the, like we are getting the maximum value, minimum value, and getting this difference interval, right? And using that, we are calculating the residue, like max well minus min well mod of this. So I think it's not that what I was talking. Yeah, you're correct.
Yeah, you are doing that arithmetic progression itself. You are checking whether A plus D are there or not.
Yeah, but this is not exactly the pigeonhole principle, right? That
No,
yeah, it's not pigeonhole.
It's not. But yeah, then when we went on discussing about that, it was similar. But what Uday says is that you could actually use a hash map and you can store the previous values. So you can always compare. When you have a difference, that is, I think, the residue, right? Or difference, diff. If you go to any element, you just find the diff. If you have that element already in that map, it means that you can say it's in that progression, right?
Yeah, I've used the map only. Dictionary. This one.
Oh, sorry. Yeah, you are using map here. Yeah. Okay. It's very difficult to make out.
Yeah, it's like one line. That's why.
Yeah.
So residue for what? Like for what we are calculating the residue?
If it says the residue is max minus minimum, then you actually.
If I didn't get residue, what?
What is
They are
this
using
if condition? If condition I didn't understand. If I mean there is no greater than 0 or something like that. Is it if 0 return false or something? If greater than 0.
Yeah, if it is 0, then it will return true in that case. Otherwise, false. Yeah, if greater than 0, it will return false.
Okay.
But you're not assigning the air length anywhere. It's not getting initialized, right? Or no? It is.
Which one?
Okay, air length is equal to length of air.
Yeah,
AR,
this is
okay.
first one, second one, third. Yeah.
Oh, it is like that.
Yeah, 1-to-1 sequence.
Oh, so you just say question equal sign in between, and then you can equate everyone. Okay.
Yeah, exactly.
Good.
Python syntax.
And so your residue says if you have those maximum value difference, then you actually just do a modulo of that with the length of that array.
So why modulo, like repeating? I mean, if same like modulo, is it for ready? This method they use because it is doing in O of n, but I couldn't get it.
No. You are actually doing so. There are n elements, and the starting element is the min element. So the last element has to be a plus n minus 1 into d. So that is what you are doing. So residue and diff are same itself, if you see.
Yeah, actually difference also the same value, maxwell minus min val divided by air length. But in this case, actually it is taking the modulo of air length. It means it's taking only whatever is the remainder, right? Residue.
Yeah.
So if you have a remainder, it means it is false. It should not be a remainder. You don't have to have a remainder in that case.
Yeah, I mean, it has to be exactly equal to, right?
Right.
Yeah. But why max minus mean? That one, max val minus mean val?
So basically, A and A, so the first element will be A, and the last element will be A plus n minus 1 into D. So you have calculated the diff. So the diff is the D. But max val minus min val will give you n minus 1 into D. So percent n minus 1. So this should be actually exactly divisible.
Or diff, yeah. The in between elements.
Yeah. So the difference between max and min should be exactly divisible by n, the tar length minus 1.
Yeah.
So that is what you are doing. Yeah. If it is not exactly divisible, you are returning false.
Yeah. And here dictionary they are using for that. What do you say? Maxwell minus A. What do you say? Oh, for every element in the array, they are subtracting.
I think that is the same itself. You are trying to form that A plus D, A plus n minus 1D, something like that. But you are trying to form from the max value.
Okay. You are going coming from the back side.
Yeah, and you are checking again in the array.
Yeah.
Cool.
Do we need a map? I wonder, maybe could we do it without a map?
No, in that case, you'll have to check many things, right? Map will be either way of doing it. It will be an O of n, linear time.
Yeah. So let's say we know the size. We know D, right? we know this, we know the gap, and we know D. So